Hello friends, in this video I am going to talk about predicting the presence of heart disease in the patients using SAS Enterprise Miner. I will also discuss importing dataset to SAS Enterprise Miner, changing variable types, handling missing values, decision tree and neural networks, and comparison of those two models, and finally the conclusion. Alright, let's go ahead and start it. Open Enterprise Miner, create a new diagram. Let's name it as heart disease model comparison. And let's import the data. We can import the data by clicking on browser here. Once the data is imported, run it and click on OK. And let us edit the variables right now. In these, few variables are incorrectly classified, like CA is actually nominal but it is classified as interval. So the same way we have to go ahead and change all the remaining variables to correct variable types. Fine, I have changed all the variable types correctly, and now finally we have to select the target variable, which is the heart disease, and click OK. And let us explore the data by pulling start explore to the diagram and then link it and then run it. We will have the results. From this output, we can find the statistics and missing values of each and every variable. So let's go ahead and start imputing these missing values. Click on Modify and pull the Impute button here. Then link the data. Change the properties of this impute. And here we have to select unique because the imputation has to be done unique to each and every variable, and the role as input, and run it. Once we have it run, we'll check the results. From the results we can see that there are three variables which have been imputed, and this age variable have been imputed with the mean, which is 54.43, and the other variables are imputed with the count. We will now partition the data. Let's link it and then let us leave them like that, like training 70, validation 30 and testing 30, and then run it. On this model we will apply regression models. Click on model and then pull decision tree here and then neural networks model here. Then link it, and we can play with the parameters over here. If you want, we can change the maximum depth to 10. This is like the it trains a tree with up to 10 generations of split. And if you want, we can change the assessment fraction, which is 0.25, and then run it. Click OK, and we will select neural networks and then run it. Click on OK. Now we will compare these two models. Click on SS, then pull the model comparison button here, and then link these two models to the model comparison button, and then click on run, and yes, and click on results. This model comparison node assembles the results numerically and graphically to help determine the best model. And looking at the ROC chart of the validation dataset, we have the decision tree line, which is far away from the baseline, which indicates that decision tree is much better and superior to the neural network model for this dataset. And when we compare these numerical results, this is the training and this is the new neural networks. The misclassification rate for decision tree is 14%, and for neural networks is 31% for training data. And when it comes to test data, it is actually 24% for decision tree and 50% for neural networks model. From all these results, we can conclude that for this data set, decision tree works much better than neural networks. Thank you for watching this video. Good luck.